There we go. Go back and let's remind ourselves. A basic trig equation. We've actually solved some of these. Trigonometric equations reminder. What is the period of the trig functions and why is this important? Let's go back and talk one more time about the period of the three trig functions. First function, y equals sine of x. I know the sine of 0 is 0, and I know the sine increases from there. Here's what sine looks like. And we know that that sine function repeats here, and it starts doing the same thing again in the same direction, or in the other direction does the exact same thing. The period of a function is how long it takes for that function to repeat. When you're dealing with sine, does anybody remember what the period was? Close. 2 pi. When you're dealing with sine, the period's 2 pi. Cosine does the exact same thing. Let's do cosine in blue. Cosine of 0 is 1, and then it comes down, dips down, goes back up. Here's cosine. Same deal. Period is how long it takes for that function to repeat. The period for cosine is also 2 pi. That's very important information. Then you've got that weird tangent function. Tangent of 0 is 0, and then it does this thing here. Right? Remember that? And then it comes over here and does the exact same thing again. It comes up through here. To where there was your tangent functions. But it repeated a little bit more often. It repeated here, then it repeated the same thing here. What was the period for the tangent function? Pi. So for sine and cosine, your period's 2 pi. For tangent, your period is pi. You need to know that for what we're about to do. For this reason, what if you're solving this equation? Sine of question mark equals 1/2. We want to know where is the sine equal to 1/2. Well, let's graph that sine function again. I know the sine of 0 is 0, does this number. Does the same thing in this direction. There's your sine curve. We want to know where is my sine curve equal to. Half would be about right here. Where's my sine curve equal to 1/2? Here's why it's going to be important to know your period of your function here. I know the sine is equal to 1/2 right here. Okay, that's where they cross. But I also know one period later, sine is also equal to 1/2 again. And I know one period previous, sine is equal to 1/2 because it repeats over and over and over. Also, I knew that in this first period, the sine was equal to 1/2 here. One period later, the same thing happens. One period previous, the exact same thing happens. So it's going to be important to know the period of the function because our answers repeat. And if I'm trying to solve the equation sine of x equals 1/2, there. If I'm trying to solve the equation sine of x equals 1/2, I've got infinite answers. But those infinite answers repeat every so often. So here's our methodology. We're going to look for all the answers within the first period. Okay? We're going to take our equations that we're solving today, look for all the answers within our first period, and then we're just going to tack on, well, and those same answers are going to repeat a period later, a period later, a period later, or a period previous. So that's our strategy. Let me make sure that's, yeah, there we go. I actually had the graph there. That'd been nice to know. There's the graph of sine of x equals 1/2, and you see what I was talking about. This answer repeats here. This answer repeated previous. Within one period, here's a second answer. That answer repeats here. That's when it's coming back downhill. And that answer repeated previous to that. Find all real numbers that satisfy each equation. The cosine of x equals 1. First equation. Cosine of x equals 1. And watch how I'm going to write this. Where is cosine equal to 1? Okay, unit circle wise, let me draw a unit circle here. Where is cosine equal to 1? Does anybody know? Is it 90? 0 degrees. Cosine is an x value, and if you take these points on this graph, here's where cosine is 1. What's cosine equal to here? -1. Okay, because its x value is negative. So is that the only place within one period? Is that the only place within 0 to 360 degrees where cosine is equal to 1? Yes. Here's how you're going to write your answers. Watch closely. So if cosine of x equals 1, then x is equal to 0 degrees. But we know that that same answer is going to occur, and I think I've got the graph right here. There we go. There's your cosine graph. We know that at 0, that the cosine is equal to 1. But again, we know that that same answer occurs 360 degrees down the road. Again, the next 360 degrees down the road. Previous 360 degrees down the road. So here's how we write it. If cosine of x is equal to 1, then x is equal to 0 degrees plus or minus 360 degrees times k. And you can tack this on the first time, but I'm not going to put it every time. What in the world does that mean? 360 degrees times k, where k is an element of, and this is just to get you prepared, I just want you to be exposed to it. K is an element of the integers. The short notation for integers is capital Z. I don't know why. And a reminder that your integers are 0, 1, 2, 3, 4, 5. It's your whole numbers. And your negative whole numbers. -1, -2, -3, -4, -5. So what that means is, your answer is 0 degrees plus or minus any whole number times 360 degrees. So that could be 0 degrees plus 1 360, 0 degrees plus 2 360s, 0 degrees plus 3 360s. Or it could be 0 degrees minus 1 360, 0 degrees minus 2 360s. Because we know that that same answer occurs every 360 degrees. Why 360? 360 is the period. That answer is going to occur another period down the road, another period down the road, 1 period down the road, 2 periods down the road. So that's the reason we tack on this k as an element of the integers. Because if that's not there, can k equal 1.2? Will that same answer occur 1.2 rotations down the road? No, just one rotation, the whole number of rotations. But honestly, guys, for as long as you know, I'll let you just put this. X is equal to 0 degrees plus or minus 360k, as long as you know in the back of your mind that k has to be a whole number. K has to be 1, 2, 3 rotations. Okay, the second answer, or second problem. Cosine of x is equal to 0. You got to be a little bit more careful here. Within one period, and I'm going to choose this period right here. Within one period, where is the cosine equal to 0? We got two answers, don't we? The cosine of y between 0 and 360 degrees, that's a whole period, 360 degrees. Between 0 and 360 degrees, where is the cosine equal to 0? At either 90 or at 270. But those answers, once again, and I'm not going to spend this much time on every problem, I just want you to understand. We know that when x is 90, that same answer is going to occur at 450. That same answer is going to occur at negative 270. So we tack on plus or minus rotations. Because 360 degrees is your period there. That same answer will occur plus 360 degrees down the road or minus 360 degrees down the road. And we do the same thing here, plus or minus rotations. And the last one, same thing. Where's the cosine equal to negative 1/2? Negative 1/2 will be about right here, here. In our one period here, well, there's a period. It looks like we're going to have two different answers. And those answers, again, recur every 360 degrees. So where is the cosine equal to 1/2? First off, what quadrant is cosine equal to negative in? Second and third. Because that's where your x value is negative, to the left. So our two answers that we're looking for here, and you notice the quadrants here? There's your first quadrant, isn't it? Because every tick mark I let count 90 degrees. There's the second quadrant. There's the third quadrant. There's the fourth quadrant. And you notice that cosine is going to be negative down here. Second and third quadrant, then it goes back positive. So what are your two answers? We have to use reference angles. The cosine of what angle in the first quadrant is 1/2. 30. Is that right? 60. Right. So reference angle 60 in the second quadrant. What angle is that? 120. And third quadrant? 240. Plus or minus 360. Okay. So if I ask you to make a list of all the solutions, let's go this step and then we'll move on. 120 is a solution, 240 is a solution. 120 plus 360, which is 480, is a solution. 120 plus 720, 840 is a solution. 120 plus 1080, which is 1200, is a solution. 240 is a solution. 240 plus 360 is a solution, which is 600. 240 plus 720, which is 960, is a solution. Infinite solutions. Okay. Cosine of x equals root 3 over 2. That's the same thing. Let's move on. Sine x. Let's deal with our sine graph now. Sine x is equal to negative 1/2. First step, find all the solutions within one period. A period of sine is 0 to 360 degrees. So we're going to find all the answers within 0 to 360 degrees. Sine is equal to negative in the third and fourth quadrants. What's your reference angle? The sine of what equals positive 1/2? Right now? 30 degrees. So 30 degrees is your reference angle, but Drake, you're in the third and fourth quadrant. Here's a 30-degree angle. Here's a 30-degree angle. Drake, this is 180, right? So what is this angle here? What's all the way around to here, and then 30 more would be 210. And Drake, this angle here, all the way around is 360, but we didn't go all the way around. We went around to here, which would be 330. So the sine of 210 and the sine of 330. Let me ask you this, though. Would it have been easier? Could I have called this negative 30? Sure. Okay. If you're in the fourth quadrant, your reference angle is 30. If you want to just call that negative 30, that's fine. Let me show you, though. We're going to get that negative 30. Plus or minus 360k, since that is a period, for sine as well. Do y'all see the negative 30? It's right here, isn't it? 330 minus a 360 would get you that negative 30. If any time you've got that negative 30 or negative 45 or negative answer, if you want to find a positive one, you don't want a negative answer here. You want to find the positive version. You can always tack on rotations. What was that called when we just tacked on rotations? What type of angles? Coterminal. So really all you're doing there is you're tacking on those coterminal angles. That's what that plus and minus 360 does. That's all your coterminal angles as well. I promise. We'll get to the tough ones here in a second. Let's do some tangents. Tangent of alpha is equal to negative 1.34. Now we're running into an issue. I don't know what alpha angle would give you a tangent of negative 1.34. So this gets into old stuff now. Since I don't know that, we use our calculator. We move the tangent over. We move tangent over by doing inverse tangent. So alpha has to equal the inverse tangent. And for somebody that's got a calculator, find that for me. The inverse tangent of negative 1.34. Round it to the nearest tenth for me. And here's something else. Since we're dealing with tangent, our period change. Period for tangent is only 0 to 180. So we only have to worry about answers in that first quadrant, or first two quadrants. Right? Wasn't that and that's what your calculator is going to give you. No, I'll tell you. Your calculator is going to give you answers between negative 90 and positive 90, which is also a whole period. That's 180 degrees. That's fine as well. What's your answer there? Alpha is equal to, or is about, negative 53.3 degrees. Plus or minus, what? 180K. The period for tangent is 180 degrees. And I want to tell you something. Honestly, I'm worried about this. I don't like that answer. Like I was telling you a while ago, I'm not a big fan of negative angles. I don't know. It just makes more sense to me if the angle's up here in the first or second quadrant. So here's what I do. That's acceptable. That's fine as an answer. But what I would do is go ahead and tack on one of those 180s. 153, negative 53.3. Let me pull up my calculator. I don't know what answer. The book might leave it like that. I don't know. Negative 53.3, but just in case. I know that negative 53.3 and 126.7 is our coterminal. So I could also write that as alpha is about 126.7 degrees plus or minus 180K. Those answers are identical. Those are the same angles. For the reason of, if I made you make a list of all those angles, it would take a while. Take this, add on 180, add on 180 again, add on 180 again, add on 180 again. Take these. Take this angle, add on 180, add on 180. You're going to get the same set of angles, if that makes sense. Okay, or subtract 180, subtract 180. Second answer, tangent of alpha equals 1. That one's a little bit easier. Alpha here. Tangent of what angle is 1? 45 degrees. So alpha is 45 degrees plus or minus your rotations. Any questions? Find all solutions in degrees to sine of 2 alpha equals 1 over root 2. Let me rewrite it. And I don't like that 1 over root 2 because we're not used to seeing it like that. 1 over root 2, when we rationalize it, would be root 2 over 2. That looks better. We can deal with that. Sine of 2 alpha equals root 2 over 2. Now you got to be cautious with this one because the sine of some angle equals root 2 over 2. This is kind of like your question mark here. The sine of what equals root 2 over 2? What angle is that? Or what angles, excuse me, there's 2 of them. The angle would be 45 degrees, right? Sine of 45 is root 2 over 2. And the sine of, let's see, what quadrants are we in here? Since sine is positive, it'd have to be here and here. Reference angle 45. We need all the answers within one rotation. What's your other answer over there? 135, good. Let me leave space. But here's the issue, guys. It's not just plain x. It's not just plain alpha. So here's what you're going to do. The sine of 45 is root 2 over 2. The sine of 135 is root 2 over 2. Root 2 over 2. So therefore, 2 alpha is either 45 or 2 alpha is 135. Plus or minus. I need to move that over. Erase so I have more room. 2 alpha is either 45 plus or minus, since you're dealing with sine. That answer occurs over 360 degrees. Plus or minus 360 degrees. Everybody good with that? Alpha's not solvable yet. But if you can get to that step from here on out, it's pretty easy. So therefore, 2 alpha is either 45 plus a rotation, or 2 alpha is either 135 plus a rotation. To get alpha by itself, what do you now do? Divide by 2. Divide everything by 2. Then. Divide by 2. Divide by 2. Cancels. So if 2 alpha is that, then alpha is 22.5 plus or minus 180K. Or alpha is 67.5 plus or minus 180K. So you see a couple of different things happening here. And by the way, you can plug that 22.5 in, and you can kind of see why that works. If you plug 22.5 in, 2 times 22.5 gives you 45. Sine of 45 is root 2 over 2. But let's go back, because I know you want to transformations for just a second. The normal period of a sine function is 360 degrees. This is not a normal sine function. What does that 2 do? It compresses it horizontally by half. So what used to be a normal period of 360 degrees is now 180 degrees. But you don't have to worry about that. I just wanted to show you where the 180 came from. You don't have to worry about that because when you divide by 2, it works itself out. That makes sense. Let's work another. Sine of 2 alpha equals 1. Let me see if I've got... Let's just do this one. The tangent of 3x equals negative root 3. Now this one's a little bit different. It says find all the solutions to this in this interval. You don't have to tack on the plus minus and all that. You're just looking for all the answers between 0 and 2 pi. For all the answers between 0 and 360 degrees. How many will there be? I don't know, honestly. Because that 3 messes it up a little bit. Normally, there's going to be 2. Where's the tangent equal to negative root 3? Normally there's 2 places where it is equal to it. But since that 3 is thrown in there, it's going to change the period. It's going to make it occur a little bit more often because it's going to compress it by a third. So let's see. The tangent of some angle is equal to negative root 3. So that angle must be what? Negative root 3. Let's say tangent's negative here and here. But we're only worried about the tangent within one period. And you can plug it into your calculator, I'd rather you not, because that's one of your common ones. You can either give me this angle, or you can give me this angle, either one. Where's tangent equal to positive root 3? 60, good job. So that's your reference angle. So let's just give this one. If 60 is your reference, then this angle must be 120. That makes sense. So therefore, tangent's either at 120 or, well, that's the only place. Within one period of tangent. And honestly, I know it's weird because normally I don't like working with tangent as well. With tangent equations, it's a little bit easier. Because think about what I said. You only need the answers within one period. One period of tangent, it's only going to have one answer there. So you don't need two different answers. There's only going to be one. So therefore, your angle has to equal 120 or some rotation of that, a period later. Divide everything by 3 to solve for x. So x is equal to 40 degrees plus or minus 60k. That's all the answers. But that's not what we want. Yes. That's it. We're only wanting the ones from 0 to 2 pi, from 0 to 360. So therefore, that's not it. Okay. This is all the answers. So now let's make a list. Let's take this and make a list of it. Your first answer is 40 degrees. Your second answer is 60 later, right? 100 degrees. Your third answer is 160. Your next answer, 220, 280, 340, 400. We're out of it, right? That's how I would rather see the answers, but unfortunately that's not how they want the answers. Because they say from 0 to 2 pi, and I've just noticed that. They didn't say 0 to 360, they said 0 to 2 pi. Anytime they're giving you an interval and radians, they're probably going to want their answer in radians. So what I should have done here, let's go back. Up here where I said 3x is equal to 120 degrees, I should have said, let's see, that's pi over 3, 2 pi over 3, plus and minus pi k. You can do it either way. If you want to get these answers and then rewrite those in terms of pi and radians, that's fine. But I'm going to take this and do the exact same thing with it. Your angle has to equal 120. Y'all see the 120 right there, right? Two 60s. Instead of plus or minus 180k plus or minus pi k. We divide everything by 3. I now have 2 pi over 9 plus or minus pi over 3k. So your answers there will be, I'm going to list them below these other answers. Let me move this. Of course. Yeah, it's not going to let me. So here we go. Your first answer is 2 pi over 9. And you can check that. Pi over 9 would be, let's see, that's 180 divided by 9 is 20. 2 20s is 40. And then we're going to tack on pi over 3s. To get a common denominator, multiply top and bottom by 3. That'd be 3 pi over 9. So instead of taking on pi over 3s, let's tack on 3 pi over 9s. So you got 2 pi over 9, 5 pi over 9, 8 pi over 9, 11 pi over 9, 14 pi over 9, 17 pi over 9, and that should be all of them. Because I noticed something. If I tacked on another 3 pi over 9, that would be 20 pi over 9. Think about that. 20 pi over 9. What's a full rotation? How many pi's? Does everybody notice that's more than 2 pi's? I meant 18 pi over 9 should be 2 pi's. Makes sense? 18 divided by 9 would be 2. So therefore 20 would be bigger than 2. So that's it. That's all of them. And these radian units here correspond with these degree units. Proof. Pi over 9 is 20. 14 times 20 is 280. It's the same angles. Any questions? Next equation. And that's all we're doing the rest of the day. We're just solving equations, just different types of equations. Find all the solutions in the interval 0 to 2 pi. Same thing. We don't have to list them all, just the ones in that interval. Of the sine of 2x equals sine x. I told you before that all those different identities that you were using, the way we were using them before was just to practice. Here's why you learned identities. Okay, it all amounts to finding solutions to equations. When you're dealing with sine, cosines, and tangents in calculus, simplifying different expressions. It's not to do proofs and all that. That's, like I said, that's just extra practice. So where is the sine of 2x equal to the sine of x? Well, that seems weird because how can you double an angle and it equals the same sine value? You would think that this is not very common, but it might be more common than you think because of like coterminal angles and stuff like that. I know one answer to this is 0 because sine of 0 equals 0. Or sine of 0 equals sine of 0. That's one solution. But let me show you how we're going to find all the other solutions. First thing I notice is that 2x is going to be hard to deal with. If you look on your sheet, and you remember from, I think it was yesterday we were doing it, that's a double angle. We can clean that up a little bit. I can take that sine of 2x out, and I can write that as 2 times the sine of x times the cosine of x. Now, here's the only dilemma now. It's really hard to solve these things when you've got sines and cosines mixed into the same equation. Now, we can do something about this. Later on, it'll be a little bit more difficult, but we can do something about this one. Watch this. I'm going to move this sine x. This other one, I'm going to move it over. So now I have 2 times the sine of x times the cosine of x minus the sine of x equals 0. Somehow try to separate if you've got 2 different functions. Because the ones we've been working up to this point only had tangents or only had sines or only had cosines. If you have 2 different types of functions, do one of 2 things. Either separate them and try to get them away from each other, or try to turn them into the same thing. I think it's going to be more trouble than it's worth trying to turn that cosine into sine stuff. So watch what I can do. Take this sine stuff here and here and factor it out. The sine of x times 2 cosine x minus 1 is equal to 0. I've separated it. I've kind of filtered it. I filtered out that sign. Now, let's relate this problem to a different type of problem. Very similar. Very simple. If two things multiply to give you 0, one of them's got to be 0. So what we can do now that we've kind of filtered out the sine away from the cosine stuff, since these two things multiply together to give us 0, then I know that either the sine of x has to be 0 or at 2 times the cosine of x minus 1 has to be 0. The first one we just finished solving. Pretty much what you've got now is two different equations. You turn one equation into two separate equations. Let's solve the first one. If the sine of x is equal to 0, then x has to be, let's see, same set of rules. When you're solving trig equations, find all the answers within one period of that function. If the sine is equal to 0, we need all the answers from 0 to 360 degrees. How many different places between 0 and 360 is sine equal to 0? I know 0. Where else? Good. Two answers. Plus or minus 360k, plus or minus 360k. There's one set of answers. So one set of answers is 0, 360, 720, 180, 540, 900. Now let's go over here. 2 times cosine of x minus 1 equals 0. We've not solved one like that. Move the 1 over, move the 2 over. The cosine of x equals what? Yeah, doesn't that look better? That's what we're used to solving. Get the cosine by itself. So now, again, within one rotation, within one period from 0 to 360, there are two different places where cosine is equal to 1/2. Autumn, can you tell me what they are? 60 degrees, and that's your reference angle as well. And then you'll have another one in the fourth quadrant, right? Good. Plus and minus 360k, because we know those same answers occur every 360 degrees because you're dealing with cosine. So there are your, I'm not going to say 4 answers, because there is your millions of answers. Because each of those answers have multiple answers, right? Now, if they told us, which, well, did they? Yeah. Find all the answers between 0 and 2 pi. Find all the answers between 0 and 360. And I'm going to go contrary to what the book says. I'm giving them in degrees. Okay? I'm not going to give them in radians. I like degrees better. So we want all the answers between 0 and 360. Did it include 360? Included 0, but not 360. So I have 0 as an answer. And the reason why I included 0 but not 360 is the same angle. Okay, 0 and 360 is identical angles, so I include both. So I know 0 degrees is one answer. Let's go over here. 60 degrees is another answer. You can tack on the 360s, but all of a sudden you're out of that quadrant, so you don't have to. 180 degrees is a third answer. 300 degrees is a fourth answer. Do you remember what the original equation was? Sine of x equals sine of 2x. The sine of 0 equals sine of 0. That makes sense. The sine of 60 equals the sine of 120. Does that work? Yeah. The sine of 180 equals the sine of 360. That one works. The sine of 300 equals the sine of 600. Sine of 300, that's fourth quadrant, reference angle 60 degrees. Sine of 600, take off a rotation, that's 240. It's in the third quadrant, reference angle is also 60. So yeah, it all works out. 0, 60, 180, and 300, there's your 4 solutions. Next problem. And here's the thing, guys. I think I made this statement before to you. The reason that, I learned this as I was in college. The reason I had to go through college and learn all this advanced math, but what I was getting at, the reason that you're having to learn this advanced math is because it makes your basic math so much easier. If you want to make really good on your ACT, learn more than what's on the ACT. Does that make sense? Learn above and beyond what's going to be on there, and then once you get to your basic problems, they're going to be easier. Like here. This is a quadratic equation. If you can solve this quadratic equation, now how much easier is it when you see this quadratic equation on the ACT? That makes sense. It's basic now. First step. I noticed that this is not your basic quadratic equation, but it's a bottoms up top quadratic equation. So my first step, and if you want to use u substitutions, if you want to take out these cosines and put in u's, that's fine, and then go back and put in the cosines later. I'm not going to. Let's work it with it. We have cosine squared x over 2 minus 7 times cosine x over 2 plus 12 equals 0. We factor. Cosine squared would be cosine times cosine. Adds to give you negative 7, multiplies to give you positive 12. What would those two numbers be, Mary? Adds to give you negative 7, multiplies to give you positive 12. Negative 3, negative 4. Since we're solving it bottoms up, though, we moved a number, right? We moved that 6, so we come back and we divide by the number we divide or moved. I now have, I'm going to put that in practice. Cosine of x over 2 minus 1/2. Cosine of x over 2 minus 2/3. Oops. Equals 0. With bottoms up factoring, let me remind you something. Next step, you would normally bring the bottom up to the top, and it would be 2 times this minus 1/2. And it would be 3 times this 2 times this minus 1, then 3 times this minus 2. If you're solving an equation, you don't have to do that. You could actually stop right here and set them both equal to 0, because it's going to end up with the exact same thing anyway. So what I'm going to do, I'm going to stop here and say the cosine of x over 2 minus 1/2 equals 0, or just equals 1/2. And the cosine of x over 2 equals 2/3. Again, normal bottoms up factoring, you would move the bottoms up. If you're solving equations, you can go ahead and set it equal to 0 and solve it. That makes sense why, because put the 2 back up here. Add 1, divide by 2, you're going to get the same thing. So now, we solve. We've got it split. It's no longer quadratic. We haven't worked one like this. You remember what x over 2 would do? Your period's normal at 360. That's going to carry the period to 720. It's going to double it. Multiplied by 1/2 doubles it. So here we go. X over 2, your angle, if the cosine of your angle is 1/2, there's 2 different answers there, isn't there? We need all the answers within 1 full period of cosine. So where is cosine, Jackson? Where's cosine equal to 1/2? Good. And we're going to have another answer in the 4th quadrant because we need a full 360 degrees. So at 60 degrees or at, good, 300. We good? But x is not by itself. Get rid of this divided by 2 by multiplying everything by 2. So your actual answers there would be, we'll do it in a different color here. X equals 120 plus and minus 720k, or x equals 600 plus or minus 720k. Second part, cosine of some angle equals 2/3. It's not one of your common ones, is it? So to solve this, we'll do a different color. To solve this, we're going to have to use inverse cosine in our calculator. That's the only way we're going to do this. But we will have 2 different answers because we know there's 2 different places where between 0 and 360 where the cosine will equal 2/3. You'll have a first quadrant answer. You'll have a 4th quadrant answer. Inverse cosine, here you go. Inverse cosine of 2/3, or has somebody done it already? No. Second cosine 2 divided by 3. About 48.2 degrees. But that's not your only answer. Cosine is positive in the 1st quadrant. Cosine is positive in the 4th quadrant. So 48.2 degrees, could I just do negative 48.2 degrees? Yeah. Positive 48.2 degrees will have the exact same cosine as negative 48.2 degrees, but I'm not a big fan of that because I'd rather have this angle instead of this angle. So what I would do is take 360, subtract that from it. I think we get 311.8 degrees. Plus and minus rotations. But again, we're not finished because we need x by itself. Let's do this one in red as well. So therefore, x would have to equal 96.4 plus and minus 720K, or x would equal 623.6 degrees plus and minus 720K. And it probably told us to find all the answers between 0 and 360. How many of those answers will be between 0 and 360? 2 of them. And that's it. Because think about it. 120, tack on another 720. Obviously that was 720 is not going to be in there. 120 is your answer. 600 is not between 0 and 360. And you can add or subtract rotations, and it's still not between 0 and 360. 96.4 is, but once you tack on the 720, it won't be in the same case with this down here. So all the answers between 0 and 360. No, actually it says find all the solutions. The red ones are all the solutions. Had it said find all the ones between 0 and 360, it would be the two blue ones. Any questions? Again, it says find all the solutions to this equation. I noticed that I've got cosine stuff mixed with sine stuff. I want to get rid of all of one, turn it into all the other, or try to separate it, is what I told you before. I don't think that's going to be factored. Here's your other tip. Here's your other hint of what to do. Cosine squared alpha minus 0.2 sine alpha equals, let's go ahead and do minus 0.9 equals 0, because that's quadratic. I don't like sine stuff mixed with cosine stuff. I can very easily change cosine stuff into sine stuff, like this. I know sine squared plus cosine squared is equal to 1. So what I'm going to do is I'm going to get rid of that cosine, turn it into sine. Move the sine squared over, and I get cosine squared is equal to 1 minus sine squared. Everybody follow what I did there? I took out cosine squared, I replaced it with 1 minus sine squared, and look what you've got now. You've got all sine stuff. It's quadratic, you're going to solve it just like you did before. Excuse me. My suggestion, well, we'll do it like this. Combine the 1 and 0.9, I now have negative sine squared minus 0.2 sine. 1 minus 0.9 is positive 0.1. But I've got negative sine squared instead of positive sine squared. Multiply everything by negative 1, which in essence simply does this. Turns this to positive, turns this to positive, and turns this to negative. Could I have moved everything to the other side to get the same effect? Can I see that? Sure. So now we've got a quadratic equation that, if you would like to, that's an alpha, by the way. If you would like to try to factor, go for it. You've got to figure out what adds to give you 0.2, multiplies to give you 0.1. Any ideas? I don't know. What's your other method? How do you solve quadratic equations if you can't factor? Quadratic formula. Be careful when you're solving quadratic formula, because you are not solving x squared plus 0.2x minus 0.1 equals 0. You're solving sine equals that. So when you get your answer is not going to be x equals something, it's going to be sine equals something. So you're going to quadratic formula. Instead of x equals, I'm going to put sine equals. The sine of alpha equals negative b plus and minus the square root of b squared minus 4ac. Somebody please do that on the calculator for me. B squared minus 4 times a, which is 1, times c, which is negative 0.1. So pretty much 0.2 squared plus 0.4. I could have done that. 0.44. Check me on that. Because I think 0.2 times 0.2, shouldn't that be 0.04? Because you need two numbers to the right of your decimal. Man, it's been a while since you've done that. Two numbers to the right of your decimal. 2 times 2 is 4. That'd be 0.04. 0.04 times 0.4 is 0.44. So 0.44 over 2a. So you've got, and I'm going to do this all on the calculator. I think it's just going to be easier. So you've got negative 0.2 plus the square root of 0.44 divided by 2. And I get 0.23166. What I would do, guys, because we're all about exact answers, let's store that. Let's store that into, let's go alpha A. Just so that I can go back and recall it. Let's see, 0.2317, I'll call it. So sine of alpha is about 0.2317. Or sine of alpha is about, we got to do the negative version too. Instead of typing all this again, you can do second entry, second entry, second entry. There it is. And I can go over here and instead of plus, put minus. And then divide by 2. Now I'm going to store that into alpha B. Negative 0.4317. Makes sense. This one's tough. This is about as hard as it gets. So now, forget everything you've done up to this point, and just pretend like you're just solving these two separate equations. Ignore the rest. And again, by the way, I stored this in alpha A, and I stored this in alpha B. To solve it now, I simply move over sign. So I've got to do the inverse sine of 0.2317. So the second sine of, that was my alpha A, right? So about 13.4 degrees, 13.39 degrees. But we got a problem there. That's not your only answer. That's one of two answers between 0 and 360 degrees. You need them both. You have a first quadrant positive sign and you have a second quadrant positive sign. To find the second quadrant positive sign, now we're getting pretty advanced, right? How do I find it? That's, go ahead. 180 minus that. 180 minus the answer. Gives you 166.61. Those are your two answers. Plus and minus, I'm going to do it together. Plus and minus 360K. I'm getting lazy. And then you do the same thing for the other. You've got inverse sine. I called that alpha B, so second sine alpha B, close parentheses. That's a negative 25.57. I don't like that answer. Right, that's, let's do this, plus 360. 334.43. 334.43. Or you've got another answer. That's quadrant 4. We should have another answer in quadrant 3. What's my reference angle, by the way? Does anybody know? 25.57. Yeah, there's your reference angle right there. The sine of negative 25.57, so 25.57, that's your reference angle. So I'm going to have another answer in the third quadrant that's going to have that exact same sine value, right? Let's do this. Let's do 360 minus my answer. That gives you your reference, 25.57. Now to give you one in the third quadrant, what are you going to tack onto that? Good. Plus 180. That gives you your third quadrant angle. 205.57. and both of those are plus and minus 360